So to start off the problem, let's first draw an isolation diagram for mass 2. So here, we see that it's accelerating to the right with acceleration A, and the only force that is acting on it in this direction is the spring force, which is given by K2 times delta X2, right? So, by Newton's second law, we have that the net force, which is K2 delta X2, is equal to the mass, m2, times its acceleration, which is A. So this means that delta X2 is just m2 times A over K2. Alright, so we got one of them now. So let's draw the isolation diagram for the second mass, which is m1. So it's also accelerating to the right with acceleration A. Now, in this case, we've got two forces acting on it. One in the direction of acceleration, which is from spring 1. So that is just K1 delta X1 by Hooke's law. And then we've got a force in the other direction from the spring with coefficient K2. So the force is given by K2 times delta X2, because delta X2 is the displacement of the spring with coefficient K2. So now, if we take the direction of the acceleration to be positive, we have that the net force, which is given by K1 delta X1 minus K2 delta X2 is equal to the mass, which is m1, times acceleration. So this means that K1 delta X1 is equal to m1a plus K2 delta X2. Now, from the first part of the question, we've already determined that K2 delta X2 is m2a. So that is m1a plus m2a, which is just m1 plus m2 times a, which means that delta X1 is equal to m1 plus m2 times a all over K1.